Here's a simple but important question. What exactly is blockchain? In this lecture, we'll introduce the basics of blockchain and all you need to know about it in easy-to-understand English. You might have already read about what blockchain is in blogs or articles, but just reading about it may be like reading from a textbook. You might not really get it. And so the best way to understand something is to actually do it. So later on in this course, we'll write codes to deepen our understanding. For now in this lecture, please just listen to the lecture and try to grasp a general image of how blockchain works. Now getting back to our question, what is blockchain? Let's say we want to send and receive cryptocurrency from others using blockchain. That's our situation, and my explanation about blockchain will be specific to this example. And you might actually send and receive between friends, so this is a transaction that you may actually face in your day-to-day activities. We'll be focusing on how your day-to-day activities can be performed using blockchain. On this left side here, we have a circle. This left side represents our traditional network where the bank is involved in transactions. The right side represents the blockchain network. First, let's go over our traditional bank-centered network. We have the bank in the center. Then, for example, let's say that this person A wants to send money. Person A can use an ATM machine or send money electronically using a web browser. This transaction is performed through the bank. The transfer request is made to the bank, and then the bank sends the payment to the recipient. That's the process of sending money, and the records of these transactions are stored in the bank's central system. The details of who sent money to who is managed by the bank system. This system exists and continues to exist because the users trust the bank. This is how the traditional way of sending money using the bank works. Now to our blockchain network. Unlike how we have a bank in the middle overseeing all the transactions, we don't have any one server managing the entire system. Instead, we have many servers that participate in the blockchain network as a group. For example, there's a transfer request from person A to person B. This transaction record being managed by everyone is the general image we should have when thinking of blockchain. Now regarding how the transaction details are stored. Let's refer to the visual on the bottom left with block. Stored inside a block, we have transactions. We keep on adding transaction details, and once we create a group with these transactions by creating a block, we'll generate a hash with this block, and then when we do create another block, we include the data from our previous hash into the new block. We have our block, our next block, and our next block, and all these are linked together. This is how data is saved in the blockchain network. It's like there's a chain linking the blocks together, so that's why we call it blockchain. For example, let's say we have person A, and this person wants to send cryptocurrency to person B. In this case, a new transaction is generated and a new block is created. When a block is created, it's created only after the other user confirms the validity of the transaction. And once confirmed to be legitimate, the block is created. You can't just create a chain of blocks all by yourself. This process is only possible with the help of others confirming the validity. After it is confirmed by the network, only at this time can the blocks be chained together. The key concept behind this is that everyone is involved in the creation of the chain. And this data that's stored in the blocks are also saved in each server, so all users are able to view the data stored inside the blocks. Now, let's say that we want to rewrite the data of this middle block and request that $1 million worth of cryptocurrency be sent to yourself. Even if you rewrite this data in your server, you'll face some problems. First, the information won't match the data that's stored in the other servers. And secondly, the rewritten information in this block won't match the data stored in the next block. And that's why this structure is very difficult to hack. Of course, if you override the data in all the servers, you could successfully hack a blockchain. But these servers exist all over the world. That means you would have to hack all the servers existing throughout the world, which sounds pretty impossible. Now let's think about who prepares these servers. Blockchain requires no central server to store data, but instead it's stored on the blockchain and is powered by many different computers. But if you buy a server and participate in the blockchain network and get nothing out of it, there's nothing attractive about it. There needs to be some benefit. So how does this all work? Let's look at when one block is linked to another block by a chain. We run an algorithm and find the nonce. At this time, the block is linked to its previous block. We'll get into the details of this process later, but with regards to running the algorithm, the server's ability to process the data quickly and guess the value of the nonce becomes important. Users compete with each other to find the value of the nonce, and the one user who is able to accomplish this, he or she earns a reward. So in the case of Bitcoin, the user will receive some amount of Bitcoins. That's the benefit of participating in this race to find the value of the nonce. Sounds pretty exciting, right? The process of deriving the value of the nonce, linking the blocks together, and receiving a reward is what we refer to as mining. And to my final point in this lecture, please note that this is a very simplified explanation of how blockchain works. PowerPoint visuals are definitely not the best to understand how blockchain works, so here I'm just introducing in simple terms how blockchain works in general, and next we'll actually write the code for it and run it. This process of textbook-like information first, followed by a hands-on approach, is what I think is best for this type of learning, especially for engineers. If you are confused with the explanation that I just provided, it's okay and just please continue. From our next lecture, I'll be writing the actual codes and this will help deepen our understanding.